Good afternoon. Pretty full room here, so let's get started. My name's David Koppe. I'm with MongoDB and our information strategy team. And what I'm going to touch on today, obviously legacy modernization is a huge topic. A lot of other keynotes this morning, a lot of other sessions around it. So we're really just going to scratch the surface here of why MongoDB is seeing approximately 30 to 40% of our businesses, folks looking at replatforming legacy modernizations onto Mongo. So we're just going to dig into sort of why, the benefits, et cetera, and talk about a couple of instances where customers have been able to do this successfully. So first of all, as far as what is it? Well, I think we all kind of get it. I think it's summed up pretty succinctly in the Modernizing Government Technology Act that 75% of the budget is spent on legacy applications, which, while it's not necessarily a bad thing in and of itself, what it does indicate is, hey, that's a lot of opportunity for systems that have been there for a while and are potentially good targets to move to a more modern stack. So in terms of what modernization means, well, this is a little bit of a marketing-y type slide, but what it really underscores is the fact that, you know, when you sort of rewind 10, 20 or more years, the role of IT and the types of systems that we saw were very different. They're really enabling functions that enabled organizations to do things more efficiently and more quickly. Pivot that to today and everything's turned on its head. Software is the business in most cases. And this really underscores, that's across multiple dimensions. The way people interact with technology is, it's not somebody coming home from work and sitting at their laptop, their desktop, doing something on the computer before they have dinner. It's constant on access from mobile applications, web applications, tablets, etc. Internet of Things, where we even take the person out of the equation, as one of the keynotes mentioned. The way businesses subscribe to software, you know, the days of spending a ton of money on perpetual software and then paying maintenance has moved to the subscription type model. The way, you know, one key theme of this conference is DevOps, deploying things way more quickly, and the way we support applications rather than spending a lot of money on dedicated hardware, cloud, agile, elastic consumption. And what all of this means is complexity. Right? Every single dimension here is complexity that multiplies on itself. And what that really means, if you sort of factor that into a typical sort of legacy type environment, is, you know, and if you think this evolved over probably decades in many cases, where there was an application identified, it was built, and it had a database. And then there was another application that was built, it needed a database, and then another and another, and all the time technology is evolving, so each application kind of has its own technology stack, including the database, but things are never that siloed in the real world, right? So then you end up with different types of databases, replication between them, reconciliation that involves processes and people, and things start to, you know, that multiplies probably exponentially. And you end up with a very inefficient and complex and fragile, and the key word that's not on there is expensive, right? It's a lot of technology, it's a lot of different software components, a lot of people time, it's a lot of delays, right? So another way to look at that is, if you think about, you know, the traditional relational model, was it invented in the 70s, matured in the 80s, came of age in the 90s, and it's been really the bedrock of database technology in the enterprise and in real production applications for many years, for good reasons that we'll come back to. But as technology has evolved and as the way we use technology has evolved, there's been additional layers factored into the application stack, right? So object relational mapping, data warehousing tools and technologies, web services to expose data to other applications. And this goes to the complexity angle, right? For every piece, every layer in here, that's potentially another software component that you probably have to license, maybe from a different vendor, so then you get compatibility issues. For every piece of software here, somebody's got to support it, so there's people behind the scenes here, and that at some point becomes untenable, right? So when you fast forward to the type of technology stack that folks are looking at today, it's a lot more simplified, right? And we'll get into the reasons of why MongoDB is a key part of that. But this is a much simpler stack. The application living on top of a much more flexible database. We break out data warehousing here because it's a little bit of a special topic that has some of its own parameters. But clearly, the right-hand side is way simpler. Simpler means cheaper, less complex, less fragile, right? So, why MongoDB? We all accept that. Great. We use a simpler technology. Well, to sort of summarize it, the way MongoDB was built was, hey, we don't have to. There's certain key things that databases have done for decades that there's a reason why the world standardized on relational, right? It's a very easy way to pull data out in very flexible ways. As your application evolved and you need to do new things that you didn't think of, it's very easy to do different SQL queries. You could add indexes to keep it performant, etc. So that method of getting to the data is very important. As a colleague of mine once said, the business value of writing something to a database is 0. The business value is when you pull it out, right? So being able to pull it out in flexible, performant ways is very, very important. Integration into the wider technology ecosystem, right? We're all technicians, so we all like thinking about feature function and you know, the bright shiny objects and the latest cool thing, but the fact that here's a piece of technology that's a key part of how an organization operates, it's got to integrate into things like your backup and restore processes. You've got to be able to monitor it to a deep, detailed level, do upgrades, etc. So having that enterprise tooling is very important as well. Strong data consistency, in some cases folks ask what is that, because it's such a table stakes capability. That is, if I write a piece of data and somebody else comes along to read it, they see that new version. Fairly simple concept, right? But in some cases that's not necessarily always the case with some tools. So MongoDB retains all of those, right? We consider those are table stakes for an enterprise database, right? What we've also done is factor in some of the reasons that people started moving away from some of the relational technologies into the general class of databases called NoSQL, which is incredibly flexible data model. You don't have that rigid third normal form spreadsheet-like definition of data that you see in a relational model. It's a lot more flexible. Highly scalable and available, not with add-on tooling, but just as part of how the database works, right? So you can scale it up globally, high availability, resiliency, et cetera. And global cloud deployments in terms of being able to consume the database in the way you choose. It doesn't have to be installed on a physical server on site. It can be virtual, it can be private cloud, it can be public cloud, it can be a managed service, it can be part of a Cloud Foundry or an OpenShift, right? And always-on availability is a key thing that isn't mentioned on here, that zero downtime upgrades, right? So what we've really done is kind of combine, hey, this is what enterprise applications need, period, end of story, non-negotiable, but all of the change and the evolution and the complexity of technology requires these capabilities, and we've condensed it into MongoDB. So this is why we're seeing that 30 to 40% of our business is around folks that are looking at using us to modernize their applications. One key thing that I want to stress is it was actually an interesting learning experience for me when I joined MongoDB a little over a year ago. That normally when you're at a software vendor and you meet someone and they say, "Oh yeah, I know your product," that's a good thing, right? Oh great, they know what I do. That's cool. That's sort of saved me about 15 conversations. And it's still a good thing at MongoDB, but I've learned that it's very important to ask the question of when was the last time you looked at Mongo, right? Because MongoDB here a couple of years ago, the term I always use is that it's kind of like watching a black and white television. Yeah, you can see the show, you can hear what's going on, but it kind of doesn't quite cut it. Because what we've done is really evolve the technology in a few key ways. One is the feature function, right? So we can do a lot more. There's a dollar lookup feature, there's a dollar graph lookup feature now. There's a lot more things that we can do, which means that now there's a lot more applications that where we have the technical capabilities to support what that application is looking to do, right? We've also, in addition, evolved the number of platforms that you can consume MongoDB on. So it used to be a physical or virtual server. We now have a Cloud Foundry integration. We work with OpenShift. MongoDB Atlas is a managed service on sort of a cloud type consumption model. So you can consume the technology in a lot of different ways, which then aligns with the way organizations are looking to evolve their infrastructure. And more tooling. Right, to that previous point, this isn't just about feature function and can you do this, can you do that? It's the fact that yes, actually we can plug into your enterprise backup capabilities. We can plug into things like App Dynamics for deep application monitoring. All of those key enterprise grade features that you need for something that you're going to start potentially betting the business on. Right, so this is a really important thing that if you've touched MongoDB a few years back, and we have webinars and sessions and material to get up to date. So that's an important thing to remember. So what the reason I stress that is that if you looked at this chart a couple of years back, clearly relational databases have been around for decades. They've got a little bit of an unfair advantage, 40 years of innovation. So clearly the most feature function rich database platform probably in the world, right? The NoSQL group of databases were really almost engineered for more niche use cases, right? So they do some things extremely well, very functional, very capable. There's a reason why they've been adopted as aggressively as they have, but the depth of functionality isn't necessarily there. There's certain workloads that don't fit well over here, but they are incredibly scalable and performant. Good things, right? So what we've done with the engineering of Mongo is, a couple of years ago, we were probably over here. But now we've started to move over to build out that depth of functionality so that we like to think that we can realistically look at supporting probably 80–90% of typical workloads, which then means that organizations can say, okay, so I'm not just moving pieces of my technology footprint onto Mongo piece by piece. I can actually start to make bigger strategic bets on Mongo as a database to support a broad set of applications, right? So that's sort of the precursor of where we think we're at. A couple of questions is, well, how does that work? How justify why I'm making the claims that I just made, right? So the first key piece is the document model database. So it's sort of interesting in a lot of meetings with folks that have grown up in a relational world. I like to write at the very beginning of the session, say, like, there's going to be some heretical concepts here. If you've never seen sort of a NoSQL database, a JSON document database, and you've always worked in a relational world, there's certain things that you're going to look at me and go, no, the earth is not flat. Wait, no, that can't be true. It's a very different way of looking at storing data, and there's very good reasons why. So, the relational model is very sort of spreadsheet-like. Break it down into a very rigorous mathematical model of, you don't replicate data, you have referential integrity. If something repeats, you break it into another table. Excellent general purpose way of representing data in a very storage efficient manner, which was important when relational technologies were invented, right? The problem is then at read time, we now have to pull all this stuff back together, right? Which brings its own level of complexity. So within MongoDB, we say, well, you don't have to define a schema. Right? Again, a little bit of a foreign concept if you're used to Oracle or DB2 or something, where an application developer has to stop what they're doing, think about the data, map it out, work with the DBA to define the schema, load it into a database, and then they can start coding. With MongoDB, one of the reasons we've become incredibly popular is you don't have to do that. It's open source, you can download the community version, load a driver that we'll talk about, and you can start writing your application. Agility, right? Agility right there. Developers can start building stuff, testing stuff. They don't have this natural break of having to get into schema design. It also means that at read time, you can build this schema, you can write this schema based on how your application actually works, right? So we're not enforcing this slightly artificial but mathematically rigorous structure. You're able to write data to the database in the structure that makes sense to you and how the application is going to be writing and reading it, which makes it extremely performant, because if you have this is a document equivalent of a row in a relational table, what's stored together is written together. So this is all stored in one place on disk. So when you go to retrieve this document, it all comes back right away and you've got all the data that your application needs. Extremely efficient and performant, right? So because you're not having to do joins and pull everything back together, right? And it gives you the flexibility to do several of the use cases that we'll touch on. That flexibility when folks are looking at, if you remember that siloed, application database, application database, application database, when you've got a business need to look across those silos, that can become very difficult because each application has its own view of the data. Well, we've got some inherent flexibility in here to model the data as you need. Right? So that's really the key, one of the key things that makes us very, very different to a relational world. The other is just how the product is built. So I mentioned that relational databases have been around for 30, 40 years, and that's a little bit of an unfair advantage they have is just that depth of engineering. You turn it on its head, and that's actually an unfair advantage to us, right? MongoDB was conceived 10 years ago, and I think we first shipped product in 2009. So the product was built and architected in modern internet, cloud, Java, mobile apps potentially, always on, scalability world. So a lot of this stuff is just architected in from the ground up. The first concept is this of a replica set, right, where the default deployment module of a MongoDB database is a 3-node cluster. You can do one if you're in development, but any sort of production instance is going to have 3 nodes, primary and 2 secondaries. Okay? An application writes to the primary, and the database handles replication down to the secondaries. No additional tooling, no more products that you've got to license, it just does it. Even the community version does that. Right? And the key thing is, notice the box here? The application doesn't know about this structure and doesn't need to know. All it's doing is saying, write my Java class out to the database. Right? And all of that replication is handled just by MongoDB itself, which brings some, and we primarily do that for resiliency and availability, so that if the primary fails, the secondaries say, they're constantly talking to each other, so the secondaries say, I haven't seen the primary in a while, I think it's gone, and they have an election that decides which one will then become the primary. It becomes the primary, and all of a sudden the application's working again. No application cut over or anything like that. That 3-node replica set can be up to 50 nodes, and I think we have one customer that's actually using the 50. Going that high is fairly rare, but technically you can do that, and there's a good reason why you would want to, because what it also opens up is you cannot write to secondaries. That's how we guarantee consistency. There's other databases which do allow you to write to them, which brings its own set of challenges in the eventual consistency type space, but you can read from them. So if you have, say, an analytical workload that needs to go crunch a whole bunch of data in the database, you can have that analytical workload look at one of the secondaries. Your main real-time operational application is still chugging along here, but you're reading from a completely different server. Right? So it gives you that sort of workload segregation possibilities that you can factor in. The other thing that, that didn't really build very well, but to then build on that concept is what we call sharding, which is partitioning, where that replica set you can break out into multiple, right? So let's say, and essentially what that gives you is parallel processing, right? So that can just be a random split of just spread my data across my shards and just randomly spread it over a hash based. It can be geo based. So this could be East Coast, West Coast, Midwest, international, or consumers with a last name A to F, however you choose the shard key. So that gives you a way to spread that geographically, spread it across multiple pieces of hardware for scalability purposes. And again, the application doesn't care, right? Which means you don't have to build an application code to deal with this. It's all just invisible to how the application works, which means as you scale up or down or out this infrastructure underneath, the application needs 0 changes. What it also means is that you can then, and the whole point of this slide doesn't show up because there's actually a map of the world that's completely invisible here. So North America, Europe, Asia, okay? I see it on there, it's just not up here. But you can split these nodes, these are each of the primary and secondaries, you can spread them around, right? So that you're now resilient to a data center failure, okay? And all of this is just how the product works, okay? And all of that is actually part of the community version and with enhanced tooling in the enterprise version, right? Because it was very critical to us that the community version had to be a fully functional database, end of story. We didn't want to get into the situation of, yeah, you can download MongoDB, but you can't really use it until you pay us. That, we want it to be a fully functional standalone database. So that's sort of the architecture. And think about in a relational world, to accomplish this, how many additional tools do you need? What size hardware do you need? You know, do you need big Exadata boxes? Do you need multiple cores? How much memory? Do you need faster dedicated disk that becomes expensive? This is all on commodity hardware and storage. It's a very, very different model to what you might be used to. And the third point I think about the product is drivers, right? So we have drivers for all the common programming languages. So as I mentioned before, if you're writing a program in Java, you work with an instance of a Java class. You set the values, you write it, and the MongoDB Java driver writes it out to the database. You read something, you do a MongoDB query, it returns classes, right? And same for all the other languages, right? So the developer isn't having to stop and say, okay, I need to do something with my database now. Well, let me write a SQL query, okay, get the results back, and then have to map it into different variables, etc. The database is, we commonly refer to it as a JSON document model. It actually is stored on disk as BSON, which is binary JSON. If you know JSON very well, you know it's got about 3 data types. Binary JSON is much more strongly typed. So if you write a date, it's a date. It's not a string that looks like a date. It is a date, right? So all of that type fidelity is maintained between the application and the database. So the net result there is it's a lot easier for developers to build applications, test applications. It's a lot easier for operations to deploy the application across a larger footprint, to scale it up and down, etc. Okay. So to really sort of tie it back together, this is the diagram that we started with, which is, so, you know, applications each having their own technology stack, their own set of databases. A very common deployment model that's been alluded to or mentioned here is this concept of, you know, the microservices API layer. And we're seeing many, many customers moving towards this in terms of an operational data layer built on top of MongoDB that then provides that very easy way of scaling each microservice up and down. So, you know, when you think about a microservice, it's essentially a tiny application that has a small amount of data it's responsible for. So if, you know, you don't really need a full complex relational stack for every single one of those microservices. So MongoDB is a very small footprint, easy to maintain database that fits very well in that, and it allows you, because of the flexible data model, it allows you to iterate very quickly through changes to that data, through that microservice. And specifically in terms of sort of legacy modernization, one of the things that you might be looking at here is, well, hold on a second, isn't this all my old applications still running down here? The answer to that is, well, yes, because what we actually see is a very popular methodology with customers is, hey, especially in the mainframe space, customers don't necessarily want to hear, hey, guess what? We're going to help you rewrite that application that's been out there for 40 years. Gets customers a little nervous, right? There's a lot of risk involved in that. And they're not necessarily looking to do that right now. So what works a lot better is, the challenge that customers have is, if you've got data locked away in a mainframe here, and yet you're moving towards a cloud and mobile first strategy, the typical use case is, hey, I've got my mobile phone and, you know, I want to check my balance. I want to see where my refund is. I want to see where my citizenship application is. Oh, all that sort of stuff I need to access. I'm on my phone going like this 1,500 times a day, right? If every time you do that is triggering a mainframe transaction, then all of a sudden that 75% of the federal IT budget is going to start nudging up towards 80%, because that becomes very, very expensive and very impractical in a real world scenario. So what we're able to do is essentially provide that single view of data across all of those disparate data sets that's extremely easily consumable by a microservices and mobile first environment. Right? And then over time, that gives you the ability, what we typically see customers doing is, there's some sort of need, whether it's a mobile app or new application, new website, whatever it is, this satisfies the need in an extremely cost-effective way. And then you can start looking at, well, other modules on the mainframe, other relational applications, other flat file feeds that we can start phasing out over time. Right? And that's really, when you're looking at a large, complex technology estate, that's the approach you want to take, is being able to do it in small, bite-sized chunks that are delivering value at each step. And that's really the methodology we try and espouse at MongoDB. So, there's various agencies, VAs, data access services, is a similar architecture to this, where you're aggregating data across from multiple silos and exposing it in a very easily consumable way. Data fabric is a typical term, channelized data services, etc. And that's really the vehicle that we're using to help customers modernize their architectures. Really good example. This moves forward. Is we have our annual user conference, MongoDB World in Chicago in a couple of weeks, and one of the reasons is the City of Chicago actually implemented a system a few years back now called Windy Grid, which was exactly the scenario from the previous slide, where they had each department within the City of Chicago had their own applications that worked for their own purposes, and maybe they worked very well, but they wanted to provide a cross-city view of services as far as instances of data from different departments being pulled together, and we were able to help them do that, not just by aggregating the data together, but also if you think about things like geospatial, unstructured, semi-structured data, MongoDB can consume that very, very easily, which in a relational model is a lot more difficult to represent. So we're really enabling them to do that, and they've actually since taken the step, I think it's mentioned on here, where they actually are now able to publish some of that data to the public through an API, so other folks can innovate on top of that platform. So once you've got all this data together in a very cost-effective platform, think of the other things that you can do down the line. So enabling that pathway to modernization is really kind of the key takeaway here. And they're actually going to be speaking at MongoDB World, as I mentioned, in Chicago in a couple of weeks. So that's what I had. I think we have a couple of minutes if there's any questions or any thoughts or comments. Yeah, go ahead.
I just always have the hardest time making choice. Like, I want to do more Mongo or NoSQL projects. At one point I was in a boot camp, and I think afterwards, hindsight, I was doing like a social type project in the camp, and totally should have done Mongo for that. Would have been perfect, way better than we just had the most awful SQL statements you've ever seen with joins all over the place, and it was a total mess. But they worked, and they only needed to work for a week, so it was fun.
Okay.
But then when I go back to like more real world scenarios, I keep finding myself like, and I think it may be a comfort level thing, most likely because that's where my background is, but it said strong data consistency, but I think of it like it's more denormalized, where the data is spread out and more repeated, and if you have to update it and maintain it, it's easier if it's normalized. And then I get into that idea that like maybe on the social site it's not a big deal if the data's not as accurate or as consistent than it is most applications in the government or those kinds of projects. You don't feel like you have really much flexibility there at all, so you're really like overly concerned with data consistency, accuracy, and also you want to be able to update it very easily. And it could be one of those things where you push push yourself over a little bit farther as far as functionality goes, and I just want to know if you could speak.
I think, yeah, absolutely. I think the key of what you're saying is it's new. It's a little uncomfortable if you're used to a relational world. That's very, very common. I would probably say every single one of our customers started with a small project, maybe even a community-based project, and built up a level of comfort, understood, okay, this is how it works, build out a capability. There's a little bit of a jump where, if you're going to get into the enterprise licensing and tooling, that's a transaction that involves funding, et cetera. So we need to work with you to do that. I think just on the, and then so once they've built that initial application, then they typically go from there, because then the comfort level is there. And it's not us saying, oh yeah, you don't need to worry about it. You've seen it and you say, oh, okay, yeah, I see how that works. And in terms of consistency, we are, one of the key things I want to make sure that I stress is we are ACID compliant at the document level. So if you have a document with 200 fields and you update 100 of them, they will all get written or none of them will get written. So it's not an issue of consistency in terms of we're not ACID compliant. We absolutely are at the document level. And in terms of data replication, you don't necessarily need to replicate data. I think the key thing I'd like to say about the lack of a schema is we're giving you the flexibility to model the data according to the application, right?
Yeah, it's very model friendly. That's
Yeah,
what you like
yeah.
about when you're in the application.
Exactly. Now, with great flexibility comes great responsibility, right? So yes, every single document in the database can look completely different. Is that a good idea? Generally, no. So a key part of any of these initial engagements is having one of our pre-sales guys or something walk through, okay, what does the application do, and what's the best practice for how should I model that schema, right? And we have document validation now. One of the items on the maturity thing was document validation. So now you can enforce certain key structures. If a document has to have a first name, last name, date of birth, and either a phone number or an email, you can enforce that, right? So we're trying to hit that sweet spot of, there's certain things that have to be true about the database, and we need to be able to give you the tooling to do that, but we're not trying to force you into a certain way of representing the data, which the relational model do. So I think I totally take your point. I think it is a comfort level within organizations, and it's a curve. I don't think we have any customers that went from no MongoDB to big mission critical applications day one. Does that answer your question?
Yeah, I mean, I'm open to use it at some point.
Okay.
Like you said, I'd like to start smaller and have something that can kind
That's-
of grow. And
That's
so.
quite honestly, that's what we recommend, right? Because if you start doing too much too soon, the likelihood of you failing or not having a great experience is higher, and that doesn't do anybody any good. Doesn't do us any good. Doesn't do you any good. So, okay. I think we're out of time. So thanks for your time. We'll connect that. Thank you.